SPC techniques persist under stable, longitudinal production runs. The amount of data required may be prohibitive for many reasons. Short-run charting may be desirable when the production lot size or sample size is extremely small. Individual moving range and moving average moving range charts are solutions for this scenario, but there are other techniques we will explore. Of course, we can always deploy first and last piece inspection, 100% inspection, or a canvas of charts for each part configuration, but these alternatives are highly complex and costly. EWMA stands for exponentially weighted and moving average. It is a variant of an arithmetic moving average chart. Instead of weighting each point equally, the weights decrease exponentially going back in time. The largest weight is given to the most recent point. The chart's memory fades over time. EWMA can detect small shifts quickly. It smooths variation and can predict the next value in an unstable environment. EWMA best works with normally behaved data, but it is very robust when normality is violated. It requires continuous, time-ordered data. The algorithm for finding the exponentially weighted statistic is based on the raw data given by X sub I, the previous exponentially weighted statistic, and a memory factor, lambda. Lambda controls the rate at which older data enters into the calculation. We typically set lambda at 0.2 or 0.3. The memory factor ranges from 0 to 1. Note that the estimate for the starting exponentially weighted statistic, y sub 0, is the mean of the historical data. Let's consider this data set. The data on the left is raw data that must be converted into exponentially weighted data. The data on the right is the exponentially weighted data. We assume the memory factor is 0.2. Using technology, we get the EWMA control chart. Clearly, the process is in control, since all values lie within the limits. However, there seems to be a trend upward that could be an early indicator of issues to come. Another short-run approach is a variation chart. The variation chart consists of the range of each subgroup divided by the average range. The lower control limit and the upper control limit are the anti-biasing constants D3 and D4 respectively. Recall that these values were presented in a previous lesson and are based on the subgroup size. Variation charts allow for the intermingling of data from a single production run, multiple products on a single machine, or different measurements of the same part all on the same control chart under standard rules of interpretation. This can only be done as long as the range of the parts is closely the same. Put another way, the range of any group cannot be more than 30% higher than the total range. A means chart is another alternative short-run method. Here we borrow from our understanding of standardization and the normal distribution to construct a Z statistic. This statistic is each data value subtracted from the grand average and divided by the average range. Essentially, each data value is transformed into a relative distance from the grand average in units of the average range. The upper and lower control limits are plus and minus A2. As you recall, A2 is one of the many anti-biasing constants summarized earlier. Recall that A2 is a function of subgroup size. Means charts also allow for the same intermingling of data on the same control chart and under the same standard rules of interpretation as discussed previously with variation charts.